Solving equations with variables on both sides. So we've looked at multi-step equations where the variable's on one side and we have to do multiple operations to get the variable by itself. Let's look at equations where there's a variable on both sides, and we'll have to take kind of more steps to get that variable alone. That's always our goal, to get the variable by itself. 8 plus 5c equals 7c plus 2. So notice we have c on the left and c on the right. So our goal is really to take a look at getting every term that has the variable in it on one side and every term that is a constant on the opposite side, because then we can divide from there and kind of finish it off. So I'm going to try to get all my 5c and my 7c on the same side. I've chosen to subtract 5c from each side. You could easily subtract 7c also, that would work. I end up with 8 on the left, 7c minus 5c is 2c, plus 2 on my right. Now I want to get all the constants on the other side away from my variable. I'm going to subtract 2 from both sides. I end up with 6 equals 2c. Now we're here to straightforward, just divide by 2, and I end up with c equals 3. I'm still encouraging you to do a mental math check of any time you solve an algebraic equation. If I throw my 3 back in here for c, 8 plus 5 times 3, 8 plus 15 gives me 23. 7 times 3 gives me 21. 21 plus 2 also gives me 23. So those two sides are equal to each other. Let's look at one with parentheses in it. I have 1/3, and then in parentheses 18 plus 12a equals 6, and then in parentheses 2a plus 7. So notice that the first thing I really need to do is worry about that distributive property with my parentheses. Not the only way you can solve it, but definitely kind of the one that we tend to gravitate toward. So 1/3 times 18, 6. 1/3 times 12a, 4a. 6 times 2a is 12a, and 6 times 7 is 42. And now it starts to look like this last problem. That's kind of what happens as we simplify things. They start to look more and more like other equations that we've worked with. So I want to get all the variables on one side and all the constants on the other. You can do that in any order that you'd like. So here I've started by getting the constants all on the same side. So I'm going to subtract 6 from both sides first. I end up with 4a equals 12a plus 36. Now I want to get, since I have all my constants on the right, I'm going to get the rest of my variables on the left. I'm going to subtract 12a from both sides. I end up with negative 8a equals 36. Divide by negative 8. Notice my fraction bar, please. And I end up with a equals negative 4.5. All right, let's look at some other equations. We've seen ones like these where we end up with these weird special solutions. Let's see what these look like. So I've got 8, and then in parentheses 5c minus 2 equals 10, and then in parentheses 32 plus 4c. I distribute those. I get 40c minus 16 on the left, and 320 plus 40c on the right. So again, I try to get all my variables on the same side. I subtract 40c, and you'll notice what happens is the variable vanishes. Please do not use a special solution until you've seen that variable completely vanish with legal moves. Then you'll know you're at a special solution. So since I have two sides that are not equal to each other, I know that I have no solution here. There's no value that I can put in here for c to make this equation true. And the last one, 4, and then in parentheses d plus 20 equals 1/5 20d plus 400. I distribute. I get 4d plus 80 equals 4d plus 80. Looking very similar here. Get rid of those variables, please. Subtract 4d from both sides. I have 80 equals 80. Since the two sides are equal to each other, I know I can put any value in there for d, and these two sides will be equal to each other. So I finish off with a solution of all real numbers.